Hello, everyone, and welcome back to the Leetcode Grind. Today, we're continuing our online assessment series with 270 closest binary search tree value. It says here that we're given the root of a binary search tree and the target value, from which we are to return the value in the binary search tree that is closest to the target. And if there happens to be multiple answers, so let's say, our target is 3.5 and we have between 2 and 4, both are 0.5 away, then we are supposed to return the smallest. So in that case, it would be, let's say this was a 3 and our target was 3.5. This was a 3, let's say, then we return the smaller of the two, the 3, which, this is different. Okay, so there's a very, just a simple way of doing things, which is we just straight up get the values in the tree. The way does not matter. We could do any traversal, but let's say we're doing in order, which is recurse all the way to the end. You get the left child, and then you take the self, and then you take the right child, then you flop back, you're back at the parent. You combine the left children, I guess, and then the self, and then the right. So let's do that. That's going to be our in order function, which takes in a node. And if the node doesn't exist, if the node is none, like we go beyond the tree, then just return empty. And then we're building the left, which is node.left. So this will be the list returned from the left side, plus the value we have from our current node, plus our traversal on node.right. Okay, so this will give us, in this instance, it'll give us 1, 2, 3, 4, 5. Okay. Now that we have the values, we want a result. I'll initialize as infinity and say for value in our helper function starting at root, if the absolute of target minus val is less than the absolute of target minus res, then update res to be our current val, and then return res. So we get the list of values in our tree. Then for each of those values, we simply apply the absolute function and see if that difference is less than our current res difference, then we update res and return res. Okay, give that a go and submit. And that does work, but note that it hints at it. Well, it doesn't hint. It says it's a binary search tree. So can we make use of that? And it turns out we can. Okay, so what can we do? We know if our target is here 3.7, do we want to explore both? Do we need to explore both? We do not. If it's 3.7, we know whatever is to the left of 4, whatever is smaller than 4, binary search tree, meaning all the values to the left will be smaller than the current, all the values to the right will be larger than the current. So in this case, 2, 1 is smaller, 3 is larger, 4, all of these are smaller, 5 is larger. So then we know that we can basically discard an entire half of the children because it will never be closer than the other side. So because our target is 3.7, which is less than our current value, we can just continue our search on the left side and continue that logic. The only caveat is, like we said before, if this happens to be a 3 and technically both 3 and 4 are, I guess, equidistant from 3.5, we do want to return the smaller of the two, which is 3. So let's apply that logic here. So we'll initialize this as root.val. We'll just start that as initial value. And then we'll have a pointer to wherever we're iterating. So we'll start that at the root And then as long as there is a node to process, we'll say, mm, we'll say that if the absolute, okay, if the absolute value of the difference between the target minus the cur dot value is less than the absolute of target minus res, then we want to update res to be cur dot value. Now keep in mind, in case there's a tie, we want to take the smaller of the two, so we'll say this is instead a tuple, so that if the first part is a tie, it'll move on to the second part and return the smaller of the two values. So let's make this a tuple as well. There we go. So cur is the node, we take its value, res is already the value, and we update accordingly. Okay. Now, we process this, we update res if the current distance is smaller. Now we need to figure out, do we continue our search on the left or the right? Well, as we said, if the target that we're looking for is less than the value in the current, we want to continue our search on the left. So let's apply that. Cur will be cur dot left. Otherwise, we'll continue our search on the right. And at the end of that, we should be able to return the res. Let's see if that works. And give that a run. Okay, there's a bonus. The bonus is the more Pythonic way of doing things. Okay, this took a little time for me to understand. Hopefully I can explain it better here. All right, so we still have the res initialized to the root's value, and we still have a node that starts at the root, and then it's basically our pointer to traverse the tree. Okay, now this part can be much shorter using the following. All right, well, maybe I'll keep that up there. Okay, so this part, what is this doing? This is basically checking which one of the two is smaller. Okay, and updating res if the new value is smaller. So we can do that by saying min. Res is going to be the minimum of our inputs here. Now, what are the inputs? The input is either res or cur.val. These are the two numbers. And how are we comparing them? Well, we're first processing them with a function. So we're passing in these two values, and we want the minimum of those two, but only after processing them with this function, which is an anonymous function, lambda val, which does this. It takes the absolute of target minus the val being either res or cur.val. It's the input that's being passed into this function. And then this will return the absolute difference, and then that will be compared. But remember, there could be a tie, and in that case, we want the smaller of the two values. So here also, we can make it into a tuple by doing this. So this function will return us the difference and the original value itself, and then those two, just like here, will be compared within this min function, and then update res accordingly. Okay, now the second part, now this part is done. The second part is a simple ternary operation. So cur will be cur dot left, this guy, if this guy, else this guy, right? So cur will continue search on the left if the target's value, target is a number, if that falls to the left of cur. Otherwise, it'll continue search on the right. And that is pretty much it. We'll give that a run and a submit. And there you have it. That was once again 270, closest binary search tree value, part of our online assessment series. Thanks so much. Happy coding and hope to see you next time.